welcome to this topic's video where we are going to take a little stop into Joe's Town and take a look at this math problem. So given these little landmark locations in Joe's Town here, our job is to find the shortest distance in miles between Joe's home and the park. So that distance right there. So as I was thinking about this video and what I was going to say in it, it became clear that I wanted to talk about dynamic text, because if I was to do something like this in my class, I think that I would have, the formula kind of working itself out. If this was, say, a conversation in the distance formula or even just Pythagorean's theorem. So this video is just going to kind of focus on the dynamic text aspect of it. I think that it's something that I want my students to do more of, even next year. Get them making text, change, because writing the expression and being conscious of it, I think, has a huge effect on their understanding. So I'll show you what I mean here. So I took this picture and I put it in GeoGebra. So here's our picture of Joe's Town, and I labeled all the points except for this point E here. And I'll show you how I did that. So this is actually Joe's home here, so we want to label this Joe's home. So I'm just going to right click the point E, go to its properties, and then you can see caption down here, and in the caption box we're going to write what we want it to say, Joe's home. And then where it says show label down here, right now it's just showing the name E, but you can have it show the caption. So now when you exit out of this, we have Joe's home as the point. Okay, so this is just a typical distance formula problem, right? If I grab my segment tool, depending on how we ask the question, what is the length of that segment? What is the distance along that path, right? From Joe's home to the park. If we're talking vectors, how far, horizontally, how far would Joe have to walk, say, west, and then how far south, right? So that's where the math really comes from. So what I thought, just to make the problem a little bit more valuable, let's just do a vector that will show where Joe starts on his walk, and then the end of the vector, the terminal point, will be where Joe ends up. And then we can do our kind of little math, little right triangle that gets formed here based off that. So I'm going to go up to the line toolbox here, and I'm going to grab the vector tool, and I'm just going to make some random vector. Say that right there. Kind of spice it up a little bit. And then I'm going to make F and G stand out so that these points kind of stand out in the problem. So here's our little vector. This kind of shows Joe's path. So it starts at point F, goes to point G, and we can move these points around. So we could say that Joe starts at his home and ends up at the park, right? Which is what that's going to show there. And the cool thing about this is we can go from Joe's home to the library or anywhere we want to. And then also, you can change your starting point. He's coming from the library to the school. How far did he walk? So that's kind of cool. Okay, so with this vector, let's show this right triangle that's always getting formed depending on where these points are. So how far down we'd have to walk, and then how far over, so that we can see the right triangle. So to do that, I want to put this point either here or here. That I'm going to construct this lower right triangle down here. So I see this point here as being the right angle. So we need to put a point that is basically the x-coordinate of f, right? We want this point to go out the same distance that f is going out. So we want the x-coordinate of f, and then we want it to go up the distance that g went, right? So we want the y-coordinate of g. So in my input bar down here, I'm going to click on it, and I'm going to insert a point. I'm going to use my parentheses, x-coordinate of f, so x of f, comma, y-coordinate of g, so y of g. So when I hit enter, there's my point H that pops up there. And so now when I move my g around, notice that point H will stay with it. So that's pretty cool, because now when we use our vector, I'm going to change up now we can see the right triangle that's always formed no matter where our points are. So now going from Joe's home to the park, we can see this right triangle that's formed. So the students would have to see that that's a distance of 2, that's a distance of 3, and then they can just use Pythagorean's theorem, which will be the dynamic text part now. So I'm going to grab the text box, this ABC tool here, and I'm just going to click up in this corner. And I think the first thing we should do is put in the abstract, the general distance formula. So I'm going to type in here, D. We'll do D for distance. D equals square root. So for make sure you have your LaTeX formula box checked here. So now I'm going to click this little arrow and we're going to go to roots and fractions, and in here we can see the square root option. So what this will do is put in the LaTeX formula code, the little backslash and square root. But you can see in the preview what's getting made right now. So whatever's in these little curvy brackets will be underneath the square root, which is going to be the x2 minus x1 quantity squared plus y2 minus y1 quantity squared, right? So to type that, I'm just going to do parenthesis. I'll just say x2 minus x1 in parenthesis, and then to square it, we're going to go shift 6, which is the caret button, and then square it. But look in our preview, we have the little, it'll superscript it for us, plus y2 minus y1 quantity squared. So there's our distance formula in general, right? So I'm going to click OK. I like to make each of my lines independent text boxes. So making sure your text selected, you can change its size and you can bold it. Maybe we'll make it large. We'll bold it and make this line say blue. Okay, so now the next one, grab the text box again, LaTeX formula. We're going to say D equals. Now in here, let's just jump right to the coordinates, the values of our coordinates. So we're going to use that x of the point, right, and then y of the point to get the x and y coordinates. So we're going to go the coordinates of the points of our green vector, right? So F is the starting point of Joe's walk, and G is where he ends up. So we'll say x and y of F, and then x and y of G when we type this in here. So let's do this. So we're going to have the D equals, we need the square root again, inside the little curvy brackets. Now I'm going to change this and put a parenthesis, but I actually want the x coordinate of, we'll take F first. Just start with that one, I guess. So what I need to do is I need a formula box so that now in our text here it'll actually show us values. So to do that, what I do, I guess the trick that I have, is I'm just going to click on an object over in the algebra window and watch what happens. Oops, not that. So, okay, what happens is you get this little box that shows up, and this is what I consider a little formula box. So I'm going to click inside the box, and I'm going to get rid of the A. I just wanted this little formula box. So that's how I get it. Now notice the preview has invalid input because we have to put something in this. Okay, so, and then we have a parenthesis we have to fix. But right now we're going to put the x coordinate of F. I'm going to type that in the box here. So this is going to be x parenthesis capital F and our parenthesis. And notice now in our preview we have 1, which is the x coordinate of our point F. So now I want to show minus the x coordinate of G and then fill this out with our values here. So each value right now is going to be its own little formula box. So outside of this box, so now I'm going to click outside of it and I'm going to put a minus. You can see in the preview what's getting made here. And now I want to put the x coordinate of our point G. So now I'm just going to type again click on something in here to get the formula box to pop up. I'm going to clean it out. And now I want the x coordinate of G. So now we have 1 minus negative 4, which is plus 4. Okay, and then outside that text box, I'm going to click outside of it, and I'm going to finish my parenthesis, and then I'm going to square the quantity. So there's x2 minus x1. And then we're going to do the same thing for y. So we're going to say plus, get a formula box. But now we want the y coordinate of f. Oh, and I need a parenthesis there after the plus. Minus y coordinate of g. Okay, so there is our distance formula with our coordinates plugged in. So now I'm going to make this large, bold it, and maybe we'll make this line red. So what's cool about this text now is that as we move our points F and G around, those coordinates will change as well, and it fills out our formula really and just shows our relationship and how the numbers are going to work. So now let's go ahead and let's do the actual difference and square each quantity. So we'll do the distance equals the square root of what number this square boils down to plus what number this square boils down to. And then we'll say equals, and then we'll add up the two numbers. And then so we'll say the square root in its unsimplified irrational form. But that's what we'll leave the text at for this video. So I'm going to grab the text box again, and I'm going to say D equals, and we need the text clicked, square root. Okay, so now in the square root, we're going to do this whole sum as a number. So I'm going to put this little calculation all in one formula box plus another formula box showing what this number is going to be. So let's click on an object, get the formula box. So now this is where I'm going to put in parentheses. We want the x coordinate of f minus the x coordinate of g. Just putting that all in one big formula box. End parenthesis, and then square it. And notice now we get 36 down here, because 4 plus 2 is 6, and then square it, we get 36. Perfect. So now we're going to go outside of the text box, and we're going to say plus, and then we're going to find out what this other square value becomes. So we want the y coordinate of f minus the y coordinate of g. Oops, and then we need to put that in parentheses so we can square that. There we go. So we got 36 plus 16. And then after this square root here, I'm going to go outside that curvy bracket. I'm going to say equals. So now we're going to put another equal after. And let's do the square root. And let's actually add these two up. So I think the easiest way to do that is I'm going to get rid of this x in the square root. I'm going to click in this first box because we want to take this value that is right now 36, and we actually want to add it to this value, which is 16. So I want all this text here in the formula box plus all this. So all I'm going to do is click in the first formula box. I'm going to go Control A just to make sure I select everything, and I'm going to copy it. So now in the square root here, I'm going to click on another object so I can get a formula box, our last one. But in this formula box, I'm going to clean it out, and then I'm going to paste the first part here. And I'm going to go ahead and click in the second formula box, and I'm going to go Control A, copy it. So now in this last formula box, here's our first quantity. We need to say plus, and then I'm going to paste the second part. And notice what that did. We have the square root of 52. So I took the text that made the 36 and actually added it to the text that made 16, right? Which then we'll add it to 52, and we're done. So I'm going to click OK. Make this large, bold it, say green. So there's our answer. There's our distance. And if we wanted to evaluate it, we could do one more step too. I'm going to double click my text. I'm going to go to the end of this thing. Outside the bracket for the square root, I'm going to say equals, and let's actually take the square root of 52. So I'm going to take this text box here that has that, really all that stuff that makes 52. I'm going to go Control A and I'm going to copy that. And then instead of equals, let's do the approximation. So I'm going to go to symbols, and in this second options, we can see these approximately, since it's going to be an irrational number. I'm going to get one more formula box. I'll clean it out, and then I'm just going to say the square root, SQRT parenthesis. So the square root of, and then I'm going to go Control V, paste everything that I have in there, and then end my parenthesis. And now we should get the approximated value of that value. So now when we go to here, go to Joe's home, back to the park, we can see that our distance is 3.61, which is really the length of that segment that we have up here too. So we are correct. So we can see, and depending on where you want to go with your talk, you can see the math always is formed and see why this formula always works. So I hope that made some sense, guys. There's a lot of dynamic text stuff going on in there, but the trick is formula boxes, and then just figuring out how you need to use them to get the text to do what you want it to do. So good luck with that.